Hi everyone, I am Balaji Chippada and welcome back to my YouTube channel. In this video, we will see what is a projection of a point onto a line or a plane, and then we will also see what are unit vectors, and we will also learn about distance of a point from a plane, and we will also learn the intuition behind all of these things. So without any delay, let's get started. So let's say I have my origin here, and then I have a line B, and I have a point A here, and the angle between this is theta. Clear? Now what is projection of a point onto a line or plane? So we take this vector A and we perpendicularly draw a line on top of B, and this length is called projection. So basically we call it as D, and this D is called projection of a point onto a line called B. And what is the distance of this one? That we will learn in this video. And let's assume we have a n-dimensional point which is n dimensions. Let's assume like that. And here we have distance of a point from an origin. So we call it as modulus of A. And this is basically, if it is a 2D, it would be root of a1 square plus a2 square, and if it is an nd, it will be a1 square plus a2 square up until an square. And mathematically this distance is given as d equal to modulus of a cos theta. So this is the formula, but in the previous videos we have also learned that if we have two vectors and if I do dot product, a dot b equal to, this is equal to modulus of a, modulus of b, and cos theta. Clear? So what I want modulus of a cos theta. So from this equation I can say modulus of a cos theta equal to a dot b by modulus of b. So if I know the points A and B, let's say A1 and A2, and then B1 and B2, even though if I don't know the theta or the angle between these 2 points, I can compute the projection of A onto this B by using this formula, A dot B by modulus of B. So this would be your D, which is equal to projection of A on B. Hopefully that is clear. And we can say that this is equal to sigma I equal to 1 to n ai and bi, and if a and b are of column vectors, by default we treat both of them as column vectors. So this is the formula of a projection, and we will understand why do we need this projection in a given minute. So let's say I have another topic called unit vector. So what is a unit vector? So let's assume I have axis like this one and this one, and I have a point A, and I will call it as A1 and A2, and this is my origin 0 comma 0, and this is x1 and this is x2, and this is a line that is connecting from origin to my point A, and this is called modulus of A. Clear? Now my A is basically A1 x1 plus A2 x2, right? Plus some value which is some bias, but let's forget about that right now. But modulus of A is equal to root of A1 square plus A2 square. So what is a unit vector? Unit vector is basically A by modulus of A. So that means A1 by root of A1 square plus A2 square into x1 plus A2 by root of A1 square plus A2 square into x2. So if I find modulus of this one, let's call it as A dash. Let's assume like this. So this would be my A dash, and if I calculate modulus of A dash, this would be equal to 1. So if you make the length of a point from the origin to be 1, that means it is called a unit vector. And how you can achieve unit vector? By dividing your vector by the modulus of A. It could be of any dimensions. So let's assume we have an n dimensions, A equal to n dimensional point. So we have something like A1, A2, A3 up until AN, right? So if I have to convert A by modulus of A, this would become A1 by root of sigma I equal to 1 to n ai square, comma a2 by root of sigma I equal to 1 to n ai square up until an by root of sigma I equal to 1 to n an square ai square. So this would be my unit vector in n dimensions. So what we will do, we will learn everything in 2D, and we will approximate in 3D, and we will also approximate in ND. So by default, modulus of a cap, which is unit vector, is equal to 1. So if it is satisfies, it is called as unit vector. Hopefully that is clear. And now we will learn distance of a point from a plane. That is also an important concept, and we will also see why do we need to learn distance of a point from a plane. But before that, let's visualize what is a plane, because in the last videos we are talking about 2D line, 3D plane, and a lot of other stuff. So I have gone through this website. This is a good one, mathinsight.org. If you look at this one, if you look at this, I have a 3D axis, x, y, and z. So this is my x, this is my y, and this is my z. And this blue color thing is called the plane, and this plane is cutting through all the axes. Clear? And we have a point in the 3D axis. This is the point. What we want to do, we want to calculate the distance of this point to this plane. We want to calculate the perpendicular distance or the shortest distance. Hopefully you are able to visualize this one. So this is my plane, and I want to calculate distance of my point to the plane. So at this one I want to calculate. So this point I will calculate from this plane. So what is this distance? So how are we going to calculate that? And why do we need this? We will also learn all of that in a given minute. We have learned about how machine learning works, right? So let's say I have 2 points like this, two set of points x1 and x2, and I will have points like this, and I will also have points like this. So what is the goal of machine learning? It want to predict the line that is separating both of these set of points, right? So in 2D it could be a line, in 3D it could be a plane. Clear? And how am I going to find the optimal distance of this plane? That in that scenario, I want to calculate the distance of every point from this plane. Let's say d1, d2, d3, d4. So by looking at these distances, and by also looking at the points distances in the other side, d1 dash, d2 dash, like this. So by looking at these distances, I will shift my plane either like this or like this to get the ideal line. So in n dimensional data, I would have to find distance of a point in a nd plane. Is that clear? By calculating these distances, I will be able to say whether it is a best fit line or not. So let's say once you trained a machine learning model and you are given a new point here, and then what we will do, you will find the distance of this point to this plane, let's say d1 double dash. And if d1 double dash is greater than 0, then I will say it belongs to class 1, else it belongs to class 0. And how are we deciding greater than 0 or less than 0? We will learn that in the next session. So before learning this concept, we need to learn how you can calculate distance of a point to a given plane. Hopefully that is clear. If you look at this website here, if you visualize this one, I want to calculate this distance of a point from this plane. Hopefully that is clear. Now let's understand how you can calculate it by yourself. So what we will do is, we will have a plane like this. Let's assume I have a plane like this. So this is my plane, and I represent it as pi if it is of n dimensions. And let's take example of 3D, because in 3D we will be better to map all of these things. And let's say I have a point P1, and it is of x1, y1, and z1. And this is my plane, right? So I want to calculate this distance. So this is of right angle triangle, and I will call it as a capital D. So I want to find this distance, right? So what I would do, I will take a point on my plane. Let's assume P0, and we call it as X0, Y0, and Z0. And I will connect this. So this is my point that I have taken onto my plane. Now from this point, I will connect these two, this P and P1. And we have seen in the previous videos, right? Distance between 2 points, let's assume as beta. So this beta is calculated as square root of x0 minus x1 whole square plus y0 minus y1 whole square plus z0 minus z1 whole square. We have learned that in the previous videos, right? And then what I would do, I will draw a line parallel to P1. So this is a line parallel to P1 which is perpendicular to my plane P, and I will call it as W as a vector. And let's assume this is of angle theta, and if it is of angle theta, this will also become an angle theta. And if you look at this, this is my vector W and this is my point. So what I want to do is I want to project this point onto this plane. We have learned the projection, right? So this would be, let's assume, some D dash. So whatever this D dash is equal to my D, because both are parallel lines and both are perpendicular here. So it is like a square. If this is equal to this one, this is equal to this one. So how to calculate this one? I just need to calculate projection of point P1 onto my perpendicular vector W. Hopefully that is clear. And we know the angle is theta and the length of this one is beta. So D dash would become like modulus of beta cos theta. We have seen the same formula, right, in here. So what is the projection of a point onto a plane? Modulus of A cos theta. So modulus of A is the distance of a point and the theta is the angle between them. And we have also seen that this is equal to A dot B by modulus of B. So what I would do here, so this would become something like this. So D dash equal to B beta dot W by modulus of W. And if it is a dot product, I can write beta transpose dot W by modulus of W. So this is my distance of a point from a plane. Hopefully that is clear. Now let's generalize and let's learn why are we learning this ones, because that is also something that matters, right? So let's take another example like this, which is I have a plane pi. So I call it as pi, and I have a vector W which is perpendicular to this plane pi. We have learned in the previous videos. And let's assume I have a point here. What I want to calculate? I want to calculate the distance of point P onto the plane pi. So what I would do from this point, I will draw a straight line like this, and this angle is called theta. And what is the distance? So this is my distance, which is same as this one. So this would be W dot P by modulus of W. So this is my D. And what I would do, I would take one more point P dash on the other side of the plane, and I will also do the same thing here. I will connect these two and I will extend this line here. So what is this distance? So I would have to calculate this distance. So this distance D dash equal to, let's assume D dash W dot P by modulus of W. Both are same. But if you look at this one, this angle with respect to this one, not in this direction, is bigger theta. It is greater than 90 degrees. Clear? So because it is greater than 90 degrees, cos theta would become negative, because cos theta would be positive if theta is equal to 0 to 90. And if theta crosses 90, cos theta would become negative value. Clear? So in short, what we will do is, if my point is on this side of my plane P, my distance would be positive, because this is equal to modulus of W modulus of P cos theta according to the dot product. So this is positive, and my D dash would be negative because it is lying on the other side of the plane. So the conclusion is something like this. Let's say I have a plane like this, which is pi, and I have multiple points on top of this one, and I have multiple points on below this line, and I will compute distance of these points from my plane, and all the distances from the one side of my plane, let's say these points, we call it as set 1 and these are set 2. So if for points in set 1 the distance is always greater than 0, for points in set 2 distance is always less than 0 if my perpendicular vector is something like this. Clear? So at a given plane we can compute the distance, and by measuring the positiveness or negativeness of the distance we can conclude whether the point is in this direction or in this direction of your given plane. And why is it useful? So let's take our traditional example. So let's say I have a 2D plane like this, I have points like this, and then I have another set of points which are like this. And what machine will do? Machine will try to predict this line or plane, let's call it as pi, and at any given point, let's say unseen point, which is p naught, and let's assume p naught lies here. So what we will do, we will find the distance of p naught d dash from my plane, and if d dash is greater than 0, it belongs to green points class, and if d dash is less than 0, that means my point should lie on this side, p naught. So this is my p naught and this would be my d dash. So if my d dash is less than 0, it belongs to purple point. So by measuring the distance of a point from a given plane, we will try to predict to which class it belongs to. So that is why we need to learn how to calculate distance of a point from a given plane, and this we will approximate to n dimensions. No matter how many dimensions we have, either it is 2D or 3D or 4D or 5D, this rule is going to stay as same. This is how machine will predict whether it is going to be in the one class or the other class. If you have any queries so far, please let me know in the comment section below. And I know this is a little bit hard topic to understand, but I want you to digest this and practice for yourself what I'm explaining, so that it will be easy for you to understand things much better. So let me rephrase what we have learned so far in the serious video. So at the start, we have learned about projection of a point. So let's say we have a point A and we have point B, and what is the projection of a point A onto the B? It is modulus of A cos theta. And by using dot product, we can also say A dot B by modulus of B. And then we have seen unit vector. So what is unit vector? We are trying to convert the vector's modulus to value 1. And how are we going to convert? We are going to divide by modulus of A. So this is called a unit vector. And then we have seen what is machine learning again, and why do we need to learn distance of a point to a plane. And then we have calculated distance of a point from a plane using all the concepts that we have learned so far. And at the end, we came to conclusion that if my point lies in one side of a plane, then the distance would be positive, and if my point lies in the other side of a plane, the distance would be negative because of the angle that is going to change between the points and the vector w. Hopefully that is clear, and we have generalized it for 2D and we have generalized it for ND. That's all for this video, guys. If you have any queries, please let me know in the comment section below. And if you are learning something new from this video, a sub to the channel would be amazing, and click that bell icon to get notified daily. And we will meet in the next video. Bye bye.